Hi, I'm Adam. In today's video, we're going to be looking at what is Fluidat and how do we use it. Bronkhorst has developed a unique database consisting of over 1,800 different fluids. We can use this tool to make various calculations. You can find this software at www.fluidat.com, and we highly encourage all of our customers to register free for this software. So let's take a look at our top 3 calculations. First, how to make a gas conversion factor. Here I have an L-Flow Select F-202 AV, currently calibrated for 100 litres normal a minute air. I want to use it with argon. So let's calibrate the argon equivalent for 100 litres normal a minute air. Select Conversion Factor in the top menu and choose the option Gas Conversion Factor. Change the destination fluid to argon. Airflow equals 100 litres normal per minute. Pressure equals 5 bar absolute for air and 5 bar absolute for argon. Temperatures remain 20 degrees C for both. From the drop-down menu, select the instrument model F-202 AV. Press the Calculate button. On the right-hand side, you will see the equivalent flow is 139.3 litres normal per minute argon. In the table below, you can also change 10 litres normal a minute to 100 and click Enter. This results in a table with flow equivalents at 25, 50, 75 and 100%. Okay, so next we're going to look at making a KV calculation. Now, why is a KV calculation important? Well, at Bronkhorst, we use the KV value or flow coefficient to size the valve correctly for your process conditions. So if you're looking to use your mass flow controller with a different gas or operating at different process pressures, then it's important to understand what the KV value is and if your mass flow controller will work at the new process conditions. Select menu option Flow Calculations in the top menu and choose the option Orifice Calculations. Let's do this calculation for 5 litres normal a minute air with an 8 bar supply pressure and a 6 bar gauge process or outlet pressure. Air is already preset, so we do not have to change this. The flow unit, pressure unit and temperature unit are also correctly pre-selected. Pressure inlet, change to 8 bar gauge. Flow, change to 5 litres normal per minute. Pressure outlet, change to 6 bar gauge. Calculate Orifice is already pre-selected, so all you now need to do is press Calculate. This results in a calculated KV value of 3 times 10 to the minus 3 and an orifice of 0.4186 millimetres. So we select the next greater size available orifice, which is 0.5 millimetres. Okay, so now we know the KV value and the correct orifice size, you can now check your current instrument and see if it's compatible with the new process conditions. Next, let's take a look at how to calculate the pressure drop across a Coriolis flow meter. First, select menu option Flow Calculations in the top menu and choose the option Pressure Difference, Coriflow and S-Flow. Let's calculate the required inlet pressure for a Coriolis mass flow meter type M14 for 10 kilograms per hour water. First, start with selecting water as the fluid. Now we choose the option for the instrument model M14 mass flow meter. and we select the actuator as none, because we'll only be measuring, not controlling. Set flow to 10 kilograms per hour. Select the option Calculate minimum required pressure inlet. And then finally, press Calculate. This results in a minimum pressure inlet required of 0.4023 bar gauge. Of course, there are many more options to demonstrate and explore within Fluidat, from vapor pressure lines, convert units, and also all of the fluid properties are available. And hopefully this video has shown you how user-friendly it is to use. So don't forget to register at www.fluidat.com.